All right, in this video, we're going to be looking at solving polynomial equations. You already know how to solve equations like 2x plus 5 equals 13, and you know how to solve things like x squared minus 4x minus 5 equals 0, okay? This one is degree 1, this one is degree 2, and these are types of equations you've dealt with quite a bit, but they're also polynomials. They're just special polynomials, okay? And you know, when you solve the quadratics, you learned that you could factor, you could use the quadratic formula, okay? Or you could wind up using the square root method. Okay, so you already know a lot about those. What we're actually going to wind up learning how to solve are things like 3x to the third minus 8x squared minus 13x plus 30 equals 0, something like that, where the degree is bigger than 2. So the degree might be 3, or you might even have one like x to the 7th minus 4x to the 5th plus 3x squared minus 2 equals 0. And it can have more than 4 terms. But anyway, that one has degree 7. And for those, we have to learn some slightly new tools. But for the most part, it's going to boil down to you being able to use the quadratic formula. Okay? So that's what I wanted to look at. Now, my usual video making technique is having issues because my Word is not working, but I think we can make this work. Okay, so I'm gonna just have to take some snips of various pieces of this to explain it, and then I'll just post the finished notes later. Okay, so let me go ahead and just introduce some of the vocabulary. This is really not a hard concept, but it just looks hard because mathematicians like to use notation that they think simplifies things, but it really doesn't. Okay, so what we're talking about trying to do is solve an equation like f of x equals x to the third plus 8x squared plus 11x minus 20, okay? And when we're doing that, it turns out there's really only 2 terms that we work with. Okay? The first one is called the leading term. Okay, and it winds up giving you the degree of the polynomial. This is called a polynomial. Gives you the degree of the polynomial, and that gives you a sense of how many zeros or how many solutions to expect. Okay, so the term with the highest exponent is the leading term, and the degree of that tells you how many solutions to expect. Okay, now the coefficient of that right there is called the leading coefficient. And so when we get around to understanding how to graph polynomials, okay, that's where the graphing of the polynomials, knowing that gives you information about what they're going to look like when you graph them, right? And then this here at the end is the constant term. Okay. All right. So all these in the middle don't really give us any information. We don't wind up using those for anything in particular. Okay. So for what we're doing, you really need to think about the degree more than anything else. And if it's degree 3, it's just telling you that you're going to have 3 solutions. All right. Now, what I really want you to understand is that we can say the same thing a number of different ways. So all of these different things here that use different terms are basically the same thing. Okay. So sometimes we use the language, the word 0. We talk about some number like 1 being a 0 of a function. 0 goes with the word function. When you have function notation, that's when you use that language. And like for our example, we're going to do in a minute, that's the x to the third plus 8x squared plus 11x minus 20. And it's when I use the f of x equals that I use the language 0, okay? But if 1 is a 0, then 1 is called a root, okay, or solution of the equation. And instead of using function notation, we just write x to the third plus 8x squared plus 11x minus 20 equals 0. Okay, and then if 1 is a root or 1 is a 0, then x minus 1 is a factor of the expression. Okay, and in our case, it would be of the expression x to the third plus 8x squared plus 11x minus 20, without the f of x and without the equal to 0, just that expression. But we can't factor that using factoring by grouping. This particular one, none of our usual factoring techniques would work. And then if the number like 1 is real, then it's going to be an x-intercept of the graph of the polynomial equation in two variables. Okay, so if I were to graph that, it would wind up being having an x-intercept everywhere I had a root or a 0. Okay, so just if they talk about a 0, a root, a factor, an x-intercept, those are all related. Okay, they're all basically the same thing. It's just a matter of the terminology. Okay. All right, so let me go back to the original page and take another snip a little bit further down. Sorry about this, but like I said, my Word document stopped working and I had to figure out a workaround. All right, so I want to go ahead on this page and talk about the whole entire process. Okay, so let me snip, see if I can get all of that. Yeah. Let me snip this portion of it and explain what's going on here. Okay, so when you're trying to do this, when you're trying to solve a polynomial equation that has a degree bigger than 2, the idea is basically to find enough nice roots, numbers like 1/2, 3, or -1, so that you can get your polynomial factored, into just linear and quadratic factors. And then you'll set those equal to 0, and you know how to solve linear equations and you know how to solve quadratic equations. Okay. And so what happens is you take, if you're starting out with f of x, so like if we have a function expressed like we were earlier, let me write it again. F of x equals x to the third plus 8x squared plus 11x minus 20, then we would write it in the form x to the third plus 8x squared plus 11x minus 20 equals 0. And then there'd be a way for us to figure out a nice root to this. Okay, there's a way to narrow down how many solutions you might have. Okay, we're not going to do that one. And then we're going to learn about synthetic division. It is super easy. Everybody does really well with that as a way of figuring out which of the nice possible solutions really work. Okay. And then once you're down to only having linear and quadratic factors, you're home free because you know how to solve both linear and quadratic equations. Okay, so that's kind of the process that we're going to use. And I didn't go into detail here because I'm going to do the example on the next page. Okay, so the possible rational zeros, this part right here, I wanted to go ahead and write down up here, can be found by taking the factors of the constant term, the one at the end, divided by the factors of the leading coefficient, the number out in front, the highest degree term. Okay, so you'll take factors of the constant term and you'll divide it by factors of the leading coefficient. And I'll show you what I mean when we do this on the next page. Okay. All right, so let me go back and let's go to the page where we're actually going to run through the examples. Okay. So let me get at least the first 3 on there and then we'll get into the work of it all. Okay, so here's like an example all worked, where we can work it out with those steps. So if we're trying to find the zeros of this function right here, okay, what we're going to wind up doing is going through that process. Okay, so first, if we're trying to find the zeros of a function, what we're really looking for is what causes that function, what causes x to the third plus 8x squared plus 11x minus 20 to equal 0. Okay, then if they don't help us out by giving us some possible solutions to this, we have to find what might be some nice possible solutions, some numbers that aren't too bad, that aren't radicals or imaginary, something pretty nice. So what we do is we look at the factors of the constant term, which is 20. Don't have to worry about the negative because you do plus or minus on all of them, divided by the factors of the leading coefficient, which in this case is 1. Okay, so that means it would be plus or minus 1, 2, 4, 5, 10, and 20, plus or minus on all of those over plus or minus 1. Then if this number out in front were something other than 1, then you might have more than one thing down here, which causes your list of possibilities to kind of increase. But for us, what I would do is do 1 over 1, that is 1. 2 over 1, that is 2. 4 over 1, and so on. But if this had been like a 1 and then also a 2, I would have to go back and do 1 over 2. And I'm going to do some other examples and show you that as well. Okay, so this is plus or minus 1, 2, 4, 5, 10, and 20. So those are the only possible nice solutions that we have to this equation in number 1. Okay. Now, what number 3 says, we don't really have to worry about. I just put that in there in case you were interested. Most of the time, we don't really make use of this, but it's just a way of narrowing down whether the solutions are positive or negative, because sometimes that can save us a lot of time when we're trying to check and see which of these really work. Okay. All right, so let me move down the page and look at the key part of this whole process. It happens on this next part. So steps 4 and 5 is where you're actually doing the work. On 4, we're going to use this process called synthetic division to check and see which possible rational roots really do work, what really are solutions to the equation, and then use it to help get the polynomial factored. And then once we've got it factored, we're home free, you'll see. Okay, so let me move this up. Let's see, I can't do it. Let me see if I can squeeze it in just a little bit and then move it up. All right, that might give me enough space. All right, so let me see if I can snip that and we'll get busy on this. Whew, glad I figured out a solution. When my Word document stopped working, I was getting desperate. Okay, so here, so we have this is the list of the possible things, possible nice solutions. Okay, so that was from before. So what we're going to do is use synthetic division to check and see which ones work. So here's what you do. So I'm going to check and see if positive 1 is a solution. Hey, let me do something, kind of just pick one out of the middle, just so you kind of see. Let me pick like 10. I want to see if 10 is a solution to that equation. Now remember the equation, let me write it again so you can see it, was x to the third plus 8x squared plus 11x minus 20 equals 0. Okay, that was what we're trying to solve, remember. So what you do is you take the coefficients of these, the 1, the 8, the 11, and the negative 20. And this process is called synthetic division. I don't know if you remember doing long division way back when, but synthetic division is just a shortcut for that you're really going to like. Now, there were no missing terms here. See how it went with an exponent of 3, then 2, then 1, then none. So that meant I didn't have to put in any placeholders. I didn't have to put in any zeros there. So here's how the process works. You bring down the first number and then you multiply. Then you add. Every time you go straight down, you're adding. Now I'm going to take 10 times 18. That's going to be 180. And then I'm going to add straight down. Okay, I can already tell this isn't working. As soon as I can tell it's not working, then I abandon it. Now, what I mean by not working is that this right here is not going to wind up being 0. Like that would be 1890 right there. So to work, this needs to be 0, which means that that would tell you that this is a solution if that turns out to be 0. So that didn't work. That means I know positive 10 doesn't work. But these others, something out of those others might work. So usually I just start at one end and I just start testing it. So you usually do this, and sometimes you have to test a lot of things before you find one that works. So I'm going through that process again. So 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 11 and 9 is 20. I like the look of that. That's 20. And see how here I get a remainder of 0. Okay. And so this helps me to see how to factor that polynomial. See, if 1 turns out being a root, it corresponds to the factor x minus 1. So it just means that polynomial can be factored into x minus 1, and then this is where you get the other piece. And this would correspond to an x to the second. So remember how this was really an x to the third right here. We were dividing by an x, and so that meant this is going to be an x to the second. So we really have x to the second plus 9x plus 20. See, this is like the a, the b, and the c on the quadratic. Okay. So the synthetic division that we just did when we got a remainder of 0, that means it works, okay? That means that this is a solution to the equation, which means that is a factor, okay? All right, so once you get it factored, if you have just x minus 1 times x squared plus 9x plus 20 equals 0, you're home free. You already know that's one of the solutions. And then here you have a quadratic equation, and you know how to solve quadratics. If they're factorable, you just factor it like this one is. And then you set those factors equal to 0, and you wind up getting your solutions. Okay, -4, -5, and +1 are the solutions. Okay, so 1, -4, -5 are zeros of f. Okay, or you could say 1, -4, -5 are solutions to that equation where we set it equal to 0. Okay, solutions or roots. It's really the same thing. All right, so that's kind of the 5-step process for solving a polynomial equation. So there's really not that much new information. You have to maybe understand how to get these possible rational solutions, and you have to get understand synthetic division, but you already know how to solve quadratics. So you really don't have a lot of new information here. Okay, so I'm going to stop this video, and then in the next one, I'll do several examples. Okay, so let me stop sharing this.